Hello everyone, welcome. This will just be a quick video showing some of the metrics and things that we look at when we're monitoring FeatureBase clusters in our um, cloud product. But they are all going to be pretty relevant to FeatureBase clusters that you're running anywhere, especially in AWS, as there are some AWS specific metrics that we can look at. This is in Datadog. You can look at similar things in other products, and probably we can make the JSON source configuration of this Datadog dashboard public if anybody wants to kind of look at that for ideas. This is all pretty straightforward host metrics for the most part, but there are a few kind of feature-based specific things that I want to call out. So first one up here is just user CPU usage by host. And then specifically, this is just user, so it's not taking system into account. No reason you probably shouldn't look at system too, but just isolating to user kind of lets you know that it's actually the feature-based process. Unless there's other processes running on the system, but hopefully you're running dedicated hosts, and it's you can get an idea of what FeatureBase is using here. This is a 3-node cluster that we're currently looking at. And then we've got load average. I think most people think they know what load average is. I think it's probably a lot more complicated than most people think. I've dug through some Linux kernel mailing lists that lead me to believe that I probably should just ignore load average for the most part, but it's there. And then here's where it gets interesting. So I'm actually going to move this. This is used memory per host. And you'll notice right down below it, we've got usable memory per host. And you'd think those two would always be the inverse of each other, but they are not, because one thing that FeatureBase does is it has a lot of things mmapped, a lot of files mmapped. And so when you mmap a file, that memory counts as being used until it gets paged out. So if you have plenty of memory and all the files you have mmapped fit in memory, it'll look like all that memory is used, but it's actually all still usable. And so I have chosen this particular bit of data to look at because we actually had a memory leak, a bug, where we were actually using memory on the heap, not mmapped memory. And so that's what you can see here. You see used memory is very high for all 3 hosts. And then down here, usable memory is almost 0 for all 3 hosts. And then we fixed the bug and we redeployed and we started ingesting a whole bunch of data. And so this is the point where we redeployed. We started ingesting data. Used memory goes up, until we have these big blocks of used memory again. And usable memory is still huge, because all the memory that not all, but 98% of the memory that FeatureBase is using is mmapped memory. So that's something to look out for. If you see your usable memory take a dive, it could be because you're running some big huge query that has a huge working set, or it could be because there's a memory leak or some other kind of bug. So definitely something to keep an eye on. Your usable memory in a steady state should generally look almost as big as your total memory on your hosts. Moving on, there's a lot of sort of disk and IO metrics, and they tend to correlate pretty well. We've got disk latency, we've got IO wait. How long is our IO operations taking? And the main thing to sort of keep in mind with these is when you're doing ingest, you'll know that you sort of hit the hardware limits when your IO wait starts spiking and your average IO time is actually a weird one. That's an AWS specific thing. It's a little bit strange, but you'll see IO wait spike, and there should be like average IO across hosts. So this is just like actual total amount of IO. So if you know how much IO bandwidth you have on your particular system, how much disk bandwidth you have or whatever, you can start to get a feel for whether you're saturating that. But you have to watch out for both bandwidth and individual IO operations. So this is ops across volumes. So these are kind of the individual IO operations. So we can see here, 135,000 ops, and I think that may be in an hour window because this is a pretty big window we're actually looking at right now. Disk usage, good one to keep an eye on, right? We've got this is where we start doing this ingest, and disk usage climbs up and up and up. And you can see that is correlated with this bulk inserts per second per host graph. And so we can see there's only one host that's getting bulk inserts. So for this particular workload, we happen to be sending all of our insert traffic to a single host. And we can see how many records per second are coming through that bulk insert query. And I actually also added a moving average to this one. So there's a kind of a smooth line and a spiky line that you can see in there. So that's the number of records that are being inserted per second through bulk insert. Over here we have bulk insert batches per second. So when you do a bulk insert, you set a batch size, and these are the number of actual batches that are coming in per second. And I think we had the batch size set pretty high, so the number's like slightly less than 1. There's network traffic on here. These are EC2 specific network traffic metrics, but you can pull host metrics that are going to look very similar. Keep in mind that on EC2, if you're using EBS volumes, those sort of count toward network traffic as well. So if you're doing a lot of writes to EBS, you should see those on your EBS charts and on your traffic, your network traffic charts. And then down here we have the SQL requests per second chart, and so this is basically any SQL query coming in will not just inserts, but any query will show up there. Okay, I think that's it. Hopefully this is helpful. And if you have any questions, we're always happy to, or feedback, we're always happy to hear either. So thanks a lot.